Hello everyone, in this video I will be explaining the problem modular mirrors. So this was asked in Codechef contest starter 238. So let's read out the problem. You are given two integers n and m. You must construct an array A of length n satisfying all of the following conditions. Okay. So what are the conditions? A of I, which is basically the array element, it should be greater than or equal to 0, less than m. For each I greater than or equal to 1, less than or equal to n. It is basically one based indexing. It is like all element of the array has to be greater than or equal to 0, less than n. So there exists at least one index I such that a of I is greater than 0. So we should have at least one element whose value is greater than 0. And for every index I with I greater than or equal to 1, less than or equal to n, a of I has to be equals to a of I has to be congruent to a of I minus 1 plus a of I plus 1 mod m. So don't worry, I'll tell you what is this. Okay, so the boundaries just outside the array are considered to be 0. Okay, that is a of 0 is 0, a of n plus 1 is 0. Here x congruent y mod m means x and y have the same remainder when divided by m. So if it is impossible to construct such an array, print -1, otherwise print any valid array. So this problem is important. I'll be telling you in detail, so you'll understand like how I came up with the solution. And yeah, so let's deal with the test case now. Like input, we have test case, and in every test case we have n and m. Okay, so they have given certain examples. 3 examples again. In the first test case, n is 5, m is 7. Okay, so before moving to test case, let's try to understand the problem statement. So so we are dealing with problem 3, and problem 3 is modular mirrors. Right, so okay, let's try to understand. In the problem, what they said is they'll be giving us n and they'll be giving us m. N is basically length of array A. Right, we need to construct an array A. Okay, now whose elements will be the elements of the array will be greater than or equal to 0, less than m. So these are the element. This is the first condition. Okay, in the second condition, what they said is, so there exists, okay, there exists at least one element a of I which is greater than 0. So this is the second condition. Now the third condition says, for every I which is greater than or equal to 1, less than or equal to 1, it is one based indexing, the array of I element has to be congruent with a of I minus 1 plus a of I plus 1 when modulo with this m, right? So this is the problem statement. Basically they'll give n and m, we need to find an array, okay, based on these conditions. This condition is very important. The array element will never exceed m, right? So this is one of the observation, and at least one element has to be a of I greater than or 0. Okay, yeah. And there may be cases like, let's say you are finding the a of 1. When you are finding a of 1, this is going to be a of 0 plus a of 2 modulo m, right? So now since it is out of bound, your array A has an element from a1, a2, a3 up to so on am. So a of 0 you do not have. So in that case it is going to be 0. And similarly a of n plus 1, n is basically size of the array, it is also 0. It's like whatever array you have constructed, right? the previous element is 0, the next element is 0, right? In that way you have to consider. Okay, so how to solve this problem? Okay, so let's move to the next page. Also they said if we are not able to find the array, we need to print -1. So how can we solve this is the question. So they'll give n and m, they'll give. Let's take example. First one, n is 5, m is 7. So now the question is, see, when you're constructing a1, a2, a3, a4 and a5 we're constructing, right? So your a1 has to be congruent with a0 plus a2 modulo m, right? So a0 they've already defined it is to be 0. So whenever you're constructing an array, your first element is 0, and this is not counted, right? Your first element is 0. Now what your a1 like one indexed is going to be is the question, right? And they have said the element whatever you have, right, it has to be lesser than m only. Either it can be 0 or it can be up till m minus 1. So I will choose, let's say, x, right? I'll choose x whose value is greater than equal to 0 but less than m. I can choose anything. So let's say I've chosen x. So when you've chosen this x, right, now very important, when you've chosen this x, okay, what would be the next element is the question, all right? Since this x is already defined, and since it is already defined, so here I'm finding this value, right? I'm finding this value. In order to find this value, what I'm doing is, your a1 is defined as x. Now your a0 is 0. Now what here what value you want, so that modulo m is equal to this. See, here for a1 you don't need to do modulo m, right? Because it is already lesser than m value, right? If it is lesser than m value, so if you do modulo with anything, I mean modulo with m, so it will be again the same value only. What I'm trying to say is, let's say your a1 is 5, okay. Now if you do modulo with 7, because this 7 is greater than 5, right? So it is going to be 5 only. And this whatever a1 value you have, right, that is in from 0 to 7, right? It lies in this region only. So that's the reason here I'm not doing modulo. So obviously, see, it is 0 and you want x, right? So this y is to be x only, not y. Okay, 0 plus x modulo m is going to be x congruent with x. You have understood, right? This y value whatever you are finding, right, which is a2, now this value is also x only. So a1 is x, a2 is x only, right? Now in order to find now this third value, how do you find that? Now your a2 is going to be a1 plus a3 modulo m. Your a2 is x, I've defined, okay. Your a1 is already x plus what, let's say this value is y, a3 value is y modulo m. Now again same question, since this is x and you want this value entire to be x, so y has to be 0, right? So y is equal to 0. So x plus 0 modulo m. So this is going to be x congruent with x. These are all congruent. So your third value, what it is going to fill with? It is going to fill with 0. I think you guys are understanding, right? In this way we need to solve. Now in order to find, let's say, the fourth value, let me don't erase. In order to find fourth value, a4 is going to be a3 plus a5 modulo m. The sorry, we are finding the fourth value, right? So for that I'll be using a3, not a4, because I'm constructing an array, right? I'm finding the values. This sixth element is already defined as 0. So here a3 is going to be a2 plus a4 modulo m. What is a3? a3 we've already defined it as 0. What is a2? a2 is x. a4 we don't know. Let's take it as y modulo m. So see, since your this y value has to be greater than or equal to 0 less than m, okay, now what value you will choose for y such that it is 0, because a3 is 0. So what value you are going to choose? Definitely you will be choosing m minus x as the y value. If you choose m minus x y value, then what it is going to happen is, I'm writing here, 0 is there, x is there. What is y value? M minus x modulo with m. So 0, this x get cancelled, m modulo m is 0 definitely. So 0 congruent with 0. Understood, right? So a4 value, what I am choosing here now? I am choosing it as m minus x, right? Okay. So similarly, if you do your a5 value, your a5 value, how do you choose? a3 plus a5 modulo m. Your a4 was m minus x, a3 is 0 plus a5, let me choose it as y, it is modulo with m. So you want m minus x here value. And one thing to note is that whatever value you have x in the starting, right? So it will be some number, let's say x is equal to 1, right? And your m in the question they have given was 7. So it will be a value wherein 7 minus 1 is 6. So here the value is 6, right? And it is always less than m only. M is 7 here. M is 7. So always 6 is less than 7. That I'm trying to say. Okay. So you have m minus x as the value, and you have 0 here, and you want the same value, right? Same remainder. So definitely your y again is going to be m minus x. So m minus x modulo m. So it is going to be m minus x congruent with m minus x, right? So your a5 value, what we got is again m minus x. Now we need to check this a5 is proper or not. So the next value, like the length of the array is 5, that is fine. The next value is 0 as said in the question, like in the constraint they had said, right? Here we have said it is 0. So we need to find if a5 is correct or not, the value what we have chosen. So now your a5 is going to be a4 plus a6 modulo m. What is a5? M minus x. What is a4? M minus x. What is a6? It is 0, right? Modulo m. So it is again m minus x congruent with m minus x. So definitely whatever array we have constructed, this is correct. Now x value we need to substitute. We can choose any value, like 1, 2, 3, 4. X value, the array what you have got is, you got x, 0, m minus x, right? And your m value is 7, n value is 5. Now x value you can choose anything. X you can choose from 0 to m. Let's say I have chosen x as 1. When you choose 1, this will be 1, 0, m is 7, 7 minus 1 is 6, this is also 6, and this is a valid array. In the question they have said, solution they have showed this thing, this is also valid one. In the solution they have said this thing, this is also valid one. So in the generalized I was telling you, like what x value you'll have to choose, right? That's the thing. So I think you guys have understood. So in this we need to find the length of the sorry, if array is possible or not. So now the question comes. So okay, for all n if it is possible or not, we need to find. Okay, so when n is 1, we need to find the, in the question that said test case n ranges from 1 to 10 power 5. So now the thing is, when n is 1, you have to choose one array, one length array. Here it will be value 0, here it will be value 0. Like a0 is 0, a1 we need to find, and here a2 is 0 as said in the question. Now how do you find a1? Here a1 is going to be a0 plus a2 modulo m. Okay, here a1 we don't know what you need to find. Okay, so a0 0 plus 0 modulo m. a1 we need to find, let's call it as x. Okay, so what if x is equal to 0? If x is 0, then this equation holds good, right? 0 congruent with 0, right? Modulo m is 0. But your array in the constant they've said at least one a of a has to be greater than 0. Since you have just one element in the array and it is 0, so this is not a possible case. So for n is equal to 1, the answer is not possible. Now let's try for n is equal to 2. If n is equal to 2, so you need to find two length array. Here the values are 0. Okay, and they'll give some m, which is like variable in LKIP, not any value. So we need to find, this is a0, a1, a2, a3. Now your a1 is going to be a0 plus a2 modulo m. Okay, so for a1 I'll choose some x value. a2 will be again x only, right? Understanding, right? Like the previous simulation I've done, the same thing, it will be x only. Okay, it is holding good. Now for a2 value, it will be a1 plus a3 modulo m. What is a2? a2 is we have chosen a, right? Like from this calculation we have got a2 as x, a1 is again x, a3 is 0. So this equation is holding good. Okay, so this equation is holding good. So it's like we have found the right thing. This, the array whatever we have, it's a good one. So for x we need to replace any value. This will be good. For n is equal to 1, we were not able to find the solution. For n is equal to 2, we are able to find the solution. Now let's see for n is equal to 3. For n is equal to 3, we need to find a solution. So first value, let's choose it as x. Okay, now you need to find a2. So in order to find a2, it is going to be a0 plus a2 modulo m. So I think you guys understand that if this value is x, this value will also be x, because this is like the left hand side of the equation and these two are right hand side of the equation. So 0 plus x, whatever x value we have, so now 0 plus something has to be equals to x, so it will be x only, right? Now when you have found out here it is x, okay, now the this is like middle element and this is like middle element and this is like this element, and we have to find this value. So what value will be putting here? Left side it is x and this value is also x, here it has to be 0, right? So I'm drawing a pattern now, right? So your pattern is going to be for n is equal to 3, x comma x comma 0. For n is equal to 1, it was pattern x and solution was not possible. For n is equal to, your pattern was x comma x and solution was possible. For n is equal to 3, this is the pattern. Let's see if solution is possible. Now these two are valid. Okay, we need to find the third value. In order to find third value, you will take second, sorry, a1 plus a3 modulo m. Now a1 is x, a3 is 1 2 3 0. My bad. This is a3, not a2. We are finding this value. if it is correct or not, right? 0 is correct or not. So it will be a2. Let me rub. So we are finding a3. It is going to be a2 plus a4 modulo m. Your a3 is 0, right? And your a2 is also x. a4 is 0 modulo m. So this is not possible, right? You have left here the value is 0. If you see, this is the middle element, left and right hand side element has to be 0 only, and this value is fixed. You cannot change because it is not in the length of the array. Your length of the array is 3, 1, 2 and 3. This is the fourth one, and this value is always 0. So as you can see, the 0 is not equals to x plus 0. So that's the reason for n is equal to 3 also it is not possible. If you try to find for n is equal to 4, your pattern is going to be x comma x comma 0 comma m minus x. If you try to see here, yeah, we have found for m is equal to 5, right? N is equal to 5. So this is the pattern that we have drawn. Okay. So if you keep on going this way, your pattern is going to be here m minus x. For n is equal to 4, it is going to be m minus x. And for this case, if you see, answer will not be possible if you do again same thing the way I'm doing it. Right, the reason being, I'll tell you what is the reason. Here it is 0, here also it is 0. This value is okay, middle value. If you do left and right hand side plus, it is equals to x. If you do the middle value, left and right side equal, right? Now if you take this value, this value get cancelled, and m modulo m is 0. So this is also valid. But if you see this as middle value and left and right as 0, so m minus x is equal to 0 mod m. So m minus x congruent to 0 is not congruent, right? So it is not possible. I think you guys are drawing pattern. So for n is equal to 5, our pattern was x comma 0 comma m minus x, right? And these values are 0. So you're drawing a pattern. Here we have x, this 0 plus is x. Middle value, left and right value equal. Middle value, left and right value equal. It is m, so modulo, if you do with m, it is 0. Middle value, left and right value equal. Middle value, left and right value equal. So the pattern that I found is, okay, so if you have a pattern this x comma x, or if you have pattern x comma 0 comma m minus x, this is possible. Here we have a solution. Now if similarly if we go for n is equal to 7, right, it will be x comma 0 comma m minus x, 0 x, sorry, n is equal to for 8. So this will be the pattern, and this pattern is valid if you add here 0 0. So all middle values will be equal, right? If you see this as middle value, these two are equal, right? If you see this as middle value, these two are equal. So the pattern what we have drawn is now at the end it has to be x or m minus s, n minus x. Now if you try to see in terms of n, if you do n modulo 3, it has to be equals to 2, right? See, 8 modulo 3 is equals to 2. Now if you try to add 3 to this, n is equal to 11 if you do. So this pattern will be again x comma 0, m minus x, 0, 6 values we have got, x 0, 9 values we have got, m minus x, 11 value we have got. It's like at the end it has to be x or m minus x, So if you try to see here, we have three these things, right, patterns, and at the end we have 2 values. So that's the reason whatever n they've given modulo 3, if you do, if that modulo you're getting as 2 as answer, so for that case answer is possible. For other case answer is not possible, right? So we have drawn, we need to write here, if n modulo 3 is equals to 2, then your answer is possible. We need to print the answer, else definitely answer is not possible. We need to print -1 and end, right? Now how do you print? See, one of the method that I've said is, see the pattern we have drawn, xx0 m minus x m minus 0 again xx0. This is the pattern. So I think now you guys have understood, and we are easily able to code it. We'll choose here x as 1 and m minus x will be, sorry, let's take x1 to be x, x2 to be m minus x, and x I'll be choosing as 1 and m minus x will be some value, like depending on m, that value will be there. So for this case, if n modulo 3 equals to, we need to print. So what I'll do is first I'll print 2 times x, then 0 I'll print, then I'll print 2 times m minus x, then 0 I'll print, then I'll choose 2 times print x, then 0, then m minus x, m minus x, right? This way I'll be printing. I think you guys have understood the problem statement and the solution, and it was a good question. So let's try to code it up. So we have test cases. For every test case we have integer n in them. So as I said, we need to check if n modulo 3 if it is equals to 2, which means answer is possible, else your answer is not possible. Right? Now how do you print the pattern x comma x, m minus x, m minus x? How do you print this? So let's take x1 to be 1, which is basically x, and your x2 is going to be m minus 1, right? Here I am choosing x equals to 1. I'm choosing. You can choose any number between 0 to m minus 1. Okay, so now I take a loop because n numbers we have to print. I'll take a boolean variable is x. Is x is basically like right now I'm printing x. So first I'll be printing x, right? So I'll be making it as true. Now I'll check here. As I've seen the pattern, see, if I take one based indexing 1 2 3 1, sorry, 1 2 3 4 5 6 7 8 9 10 11. So 0 is coming at every third position, right? First, second, third, first, second, third, first, second, third. So easily we can switch x and m minus x based on the 0. So if your index is in the for loop, if your index is modulo with 3, if I'll be starting I with 1. So if I modulo 3, if it is equal to 0, which means in this case we'll have to print 0, and then we have to switch to m minus x, right? And then again m minus x will be printing, and if it's like 6 modulo 3, it is equals to 0, so we need to again switch back to x. Okay, so here this will be one based indexing. I'll see if this I modulo 3 equals to 0, which means we have to print 0 now. Cout 0, else and cout 0, and I'll be making this is x is equals to I'll be basically inverting the value. So in the else condition we'll have to see if is x, if is x is true, we need to print x, else we need to print m minus x. Let me remove this x1 and x2, and let me take x as to be 1, right? Let's try to run it. Yeah, this is it's like they're expecting 4 and 3. In the question they have said any valid will be, if there are multiple valid arrays, any of them will be accepted. So this is going to be accepted. Let's try to submit in the code editor. So yeah, this got accepted. So in this way you could have easily solve the problem. This problem was more of doing and trial and error, dealing with multiple test cases, finding for n is equal to 1 2 3 up to so on, like 8 test cases you have to go. And then based on this value, a of 0 is always 0, a of n plus 1 is 0. So based on this value, the middle values we were able to find, right? So this was more of a intuitive problem and it was a good problem. So if you try to analyze the time complexity, see the time complexity of this will be, we are using one for loop, so it is going to be O of n, right? And space complexity, we are not using any extra space, so your space complexity is going to be constant. This is linear, this is constant. So yeah, thank you guys.